EPC, electronic product code, in this EM Micro Echo V dual frequency tag using both a UHF reader and an HF reader, as well as the native reader in the iPhone and Android phone. So first we'll start with this Marson UHF reader, which is Bluetooth connected as a HID keyboard to the iPhone, and we'll read the EPC. So I establish an active cursor position here. I have notes open, and I get my virtual keyboard, and what I'll do is I'll power up the Marson reader. Okay, so you can see the keyboard eject. Then we'll hold it near the tag, and we'll read the EPC of the tag. So here you can see 96 bits, which is represented as 12 bytes. And in the case of writing in the HF side, at least, it's written into 3 blocks of 4 bytes each. So you can kind of make out that's the first byte, the first block, second block, third block. And that'll become relevant as we dig into the other readers as well. So let me disconnect now the Marson reader so that we get our keyboard back again. So I go to Bluetooth, and I go to connected here. Oops. And I tap disconnect. Okay, so now it's disconnected. And I tap, I get my active cursor position back again. Okay, now let's go to the D600. Let's read it, use the tag using HF. Now, the HF side is 15693 or NFC Forum Type 5. That's just the Marson reader powering down. And using that, we can read using an HF reader like the Socket Mobile D600, and also you can read for the consumer experience, you can read using the iPhone or an Android phone using the native library, and we'll show that as well. First, let's use the D600. So we connect, okay. And in this case, we use a custom app. So the Marson used a HID keyboard, and the D600 used a custom app. And we have an SDK and tools and things to simplify this. This is a little demo app showing how to send commands to cards, to tags. So I go to my library and model library, and I scroll down. So I've already implemented this, obviously. And you'll see 2 here. This one is UHF, EPC, EM Micro, and this one's encapsulated. Let's do this one first. And this is using our library. So regardless of the card type, FF is send to card, B0 means read. So you have a library of different commands. There's also update binary and lock, and there's a few different commands you can use as simplified. In this case, B0 means read block. This parameter is 00, it's blank in this case. And then 61 is the location where the EPC is stored in the HF memory. And then that's the block number. And then 0C is hex for 12, and recall the 96-bit EPC is implemented in 12 bytes. So you're reading 12 bytes starting in block number 61. So then I put the D600 close to the tag, and you notice here you'll see in a moment when I press the trigger button, we'll get the ATR there. Okay, so this is answer to reset or ATR, and that's how apps and readers know what tag type is there. This is universally read regardless. As long as it's a standard, complies to one of the ISO standards, you will get an ATR number, and then based upon this, you'll know how to communicate at a lower level with the tag itself. Anyway, that's normal. You don't have to worry about that when you're doing design, doing app development, because it's handled for you in the reader. So now what I want to do is read the actual EPC. So I press the run button. Oops, there. So I get the EPC back, and I get 9,000. 9,000 is basically a status word, which means all is okay. Normally you don't bother with that. If you had an error code, you would see it there in development, and that's how you debug your design. But that is the EPC. Now if I tap share, copy, go back to notes, set an active cursor position, and oops, say paste. Okay, so you get that number back so you can see them side by side. So ignore the 9,000. And if you look at the first block, it's just that the data is the same, except the order of the byte order is different. I guess it's how it's written into the tag versus how it's sent over the channel. But you'll see E2 is trailing here, and you'll see 14 is leading here, and it's trailing there, and then the 2 bytes in between. So other than the manipulation, the data is exactly the same. So that's read using the D600 in our library. Let's go back to NFC script app. Now let's go to the library again. Remember I said there were 2 commands. Down to UHF. Right here. So now we're going to pick this one, the encapsulated. So tap encapsulated. Now this command is a little different, it's a little longer. Let me take a moment and show you ISO 15693. This is a little table and of different commands that are sent and then the responses back. And you'll see like read single block, write single block, and other commands of course, but read multiple blocks and write multiple blocks. In this case we want to read multiple blocks, so you see the 23. So you can remember that number, and go back here, you see 23. So we're reading multiple blocks starting in location 61, and we're reading 02. I think because in ISO 15693 there's an offset, so you're reading 00, 01, and 02. So you're reading the 3 blocks again in order to get your 12 bytes. So the data is just the way this is the command structure in ISO 15693. Now there's the 23 again for read multiple blocks. There's also a flag that comes before that, which is 00 in this case. It becomes a little relevant when you look at Apple versus Android, but it's the details. When you look at a command structure, you'll see this. There's the command code, so that's 61 in this case. But there's also flags, and the flags have to do with different kinds of readers and whether you have, in this case, a high data rate and a low data rate. But normally you do 00, which is just the default. But there are different options, and in the case of the tag reading we're doing here, you'll never see the difference in one versus the other. But it is important because when we show Android later on, you'll see they use a 02 here, because at least in my Android case, it does do the high data rate. But in the case here, we just do 00. We could put 02, but again, you wouldn't really notice the difference. But that's the commands. Then the part that to the left of it here, starting with 04, is the encapsulation. So we basically take the ISO commands and we can send them to the card directly and not use our library. And FF means sent to card as before, and then FE is the encapsulation, and then 05 is for the type 5, which we're talking about here. This flag is not used, pre2 is not used in this case, and 04 means that 4 bytes follow, 4, and 1, 2, 3, 4. So if you had 5, that'd be 05, etc. So that's the command structure, and normally when you do an app development, you just make a wrapper for that. Okay, so now let's do the same thing and read the tag encapsulated. I get my ATR, and I tap run. Oops, there, and I get the same answer back again. So if I put the D600 aside for a moment, and let's try reading the same tag using the native reader in the iPhone. And you'd have to have a custom app to do that and send the commands. But in order for development, you can take an app like NFC Tools. And normally you're doing reading and writing, but there's this other button here. You tap that and you see Advanced NFC Commands. And they're telling you that this is just for development. So that's that disclaimer there. What you do is you tap the search button and then you go and you find read multiple blocks. And you'll find that same familiar 23 command. So that's the one you want. So tap that, it populates. Now, remember I was talking about the flag before. Apple doesn't give you the choice. The flag is not present in the command because I guess they default to 00, which is fine. For the iPhone, it's totally fine. But so that's the 23. And then here we're starting in block 00 and reading four blocks. And that's what they told you in the library description. But in our case, we want to start in 61. That's where the EPC is located. And we want to read 3 blocks. So that's the command we want to send. 2023-6103, which of course follows ISO 15693. The only thing that's a little different is in the Apple library, I guess they say 3 blocks versus starting with 00, so the numbering is different. But I send command and tap it. And again, answer back, and it's the same. Same as reading UHF or with the D600. And I can tap share, and I can go copy, and I go to, oops, not there, I want to go to notes. Cursor position, paste. Okay. So you can see there's a little more that picked up the send as well. So that's the command sending with the arrows, and here's the data coming back. And you can see the data, the EPC is exactly the same, and the same byte order as well as read by the D600. So if you were developing an app, you can use UHF, you can use the D600. For instance, the UHF could be, let's say, for your supply chain. HF then could be, let's say, for your POS or for fulfillment center, where you need to perhaps even encode the tag. This is a full-featured consumer engagement tag. And then the iPhone side could be for your consumer experience. Now, you need to have a custom app in order to do this. You need to have a custom app. Actually, all of these would require a custom app in order to do this level of support for the tag. But it's all possible and all there. And that's using the iPhone. Now, NFC Tools also has an app for Android. And let's see, because it's a dark screen. Let me turn off the light for this one. So if you go to NFC Tools, and the same thing, launch it. Oops. Let's see. How do I get back to the main menu? So if you go to the main menu, normally this is what you're seeing when using NFC Tools. But again, you want other in this case, just like with the iPhone. You go to Advanced NFC Commands, you get a disclaimer. And I have to warn you, sometimes it doesn't work in the Android. The library, I mean, there's some interaction between all the apps running on Android, but we'll see if it works this time. So we want to select ISO 15693. Okay, so that's a little different than what you get in the iPhone. In the iPhone, it figures out based upon the tag. I guess it's reading the ATR. So the libraries are different. Then I go and look in the library itself, and this is the command that we want, read multiple blocks. Okay. And same thing, except now you're getting, oops, sorry, meeting coming up. Now you're getting the 02 flag like I was saying here. So in the case of Android, they're assuming you're getting the high-speed data rate. So that would be 02 in hex. And we want to read block number 61. So let me delete some of those. And we want to read we want to read 2 blocks. So this again is the ISO 15693 format. So it's reading it's reading a 0 offset, a 1 offset, and a 2 offset. So you're getting the same answer as if you're reading as with the iPhone with the core NFC commands. So then I say send command, I get a disclaimer, and I put the tag on the reader. Send, okay. So you're getting the same answer. It's kind of hard to put them, well, I can't paste it obviously, but if you look close at the same answer. And they are working. Now, in the case of Android, you get a bit more control over it, but Android is an open platform, and lots of apps have access to the reader. So if you're going to do this kind of work, you want to definitely make sure only one of those apps is accessing the reader at a time. But I think the iPhone does a better job. Well, it's more of a closed system, and it manages that more for you. So it's less flexible, but it's perhaps a little easier to use, whereas Android is more open. In this case, it worked perfectly fine. But just a little caveat there, if you have other apps running in the background, it may be pulling the data instead of this app. But it's all working. So the beauty of this tag is you're getting all the experiences of a consumer engagement tag. Like if I tap the close the app, tap the tag, and I'll get a URL, and I open it, and I'll get a consumer engagement experience, and the data will eventually populate for this tag. But if I have a custom app and I want to dig deeper and have some other kind of use cases where, for instance, I'm using the EPC, all that's possible using the UHF reader or using the HF reader like our D600 or S550, our tabletop readers as well. And also you can do the same using a custom app with the native readers in the iPhone and the Android. Okay, thanks.